Hello everyone, myself Ghanshyam Soni, Assistant Professor in Mechanical Engineering Department of HJD Institute of Technical Education and Research, Kutch. Today we are going to start a subject Maths-2 which is offered in a Bachelor of Engineering in Semester 2 under a Basic Science course. Today in this lecture we will discuss the content of the subject. First of all, what is the main objective to study this subject? The objective of this course is to familiarize the prospective engineers with techniques in vector calculus, ordinary differential equations, Fourier integrals, and Laplace transforms. The main aim of this course is to equip the students to deal with advanced level of mathematics and applications that would be essential for their discipline. Basically, all content of the subject is divided into 6 different units. So today in this lecture we will go through the brief about all the units. Now, basically we can divide the all 6 units of the subject into a 4 different sections. So let us first understand these 4 different sections. Now the first part of the subject is vector calculus. Engineering, physics and computer science in general, but particularly solid mechanics, aerodynamics, aeronautics, fluid flow, heat flow, electrostatics, quantum physics, laser technology, robotics, as well as other areas have applications that require understanding of vector calculus. With the aim of this, in this subject, we will discuss about the various concepts of the vector differential calculus and vector integral calculus as well as its applications in the various engineering fields. For example, convergent, divergent and various theorems related with the differential calculus and integral calculus. So this is about the part A, which deals with the vector calculus. So in part A, there is a 1 unit in your syllabus. Now part B is Laplace transform. So question is, what is the importance of Laplace transform in mathematics? Laplace transforms are invaluable for any engineer mathematical toolbox as they make a solving linear ordinary differential equation. Here the word is ODE. Here word is ODE. ODE stands for ordinary differential equations and related initial value problem as well as system of linear ordinary differential equation much easier. It means by using a Laplace transform techniques, you can solve the ordinary differential equations as well as related initial value problems much easier. The various areas of the applications of the Laplace transforms includes the electrical networks, springs, mixing problem, signal processing and other areas of engineering and physics. So as I have told, Laplace transform provide a powerful tools for solving a linear ordinary differential equations and related initial value problem as compared to other ordinary differential equation solving techniques. A Laplace transform finds a wide range of applications in electrical network, which is important for the electrical engineers, springs for mechanical engineer, mixing problems for mechanical engineer, signal processing for electronics engineer, and other areas of the engineering and physics. So this is about the Laplace transform. Now the part C is Fourier integrals. Now in your previous semester, that is in first sem mathematics 1 course, you have already learned the Fourier series. Now, but Fourier series are powerful tool for problem solving involving a functions that are periodic or are of interest on finite interval only. It means you can use the Fourier series for solving a problem that involves functions which are periodic or are of interest on a finite interval only. Now the question is, if the function is not a periodic function, then what to do? So since of course many problems involve functions that are non-periodic, and we ask what can be done to extend the method of Fourier series to such a functions. This idea will lead to a Fourier integrals. So this is about the Fourier integrals. Now the part D of the subject deals with the ordinary differential equations. Many physical laws and relations can be expressed mathematically in the form of differential equations. Indeed, many engineering problems appear as differential equations. So with a view of this, in this course, we will discuss various techniques to solve a first order differential equation as well as second and higher order differential equation. And also we will discuss about the series solution of a ordinary differential equations. So in part D, there are 3 units in your syllabus. First unit is for first order ordinary differential equation. Second unit is for the higher order ordinary differential equation. And third unit is for the series solution of ordinary differential equation. So in part A, there is 1 unit. In part B, there is 1 unit. In part C, there is also 1 unit. And in part D, there are 3 units. So totally, there are 6 units in your Mathematics 2 syllabus. Now let us understand each unit one by one briefly. So the first unit is vector calculus. In this unit, we will discuss about the parametrization of curve, arc length of curve in a space. Then we will discuss how to find a line integrals. Then we will discuss the vector fields and its application. This includes the work, circulation and flux. Then we will discuss the path independence, potential function, piecewise smooth, connected domain and simply connected domain concepts. Then after we will move to a discussion of the fundamental theorem of line integrals, conservative fields, component test for the conservative fields. And lastly, we will discuss exact differential forms, divergence, curls and green theorems in the plane. So this is the all content of the vector calculus. Now the second unit deals with the Laplace transform. So in this unit we will discuss Laplace transform and inverse Laplace transform. Then after we will discuss about the linearity and first shifting theorem. It is also known as S-shifting. Then we will discuss about the transform of derivatives and integrals and ordinary differential equations. Then after we will discuss the 2 important functions, that is unit step function, which is also known as the Heaviside function, and short impulse Dirac delta function. Then after we will discuss second shifting theorem, which is also known as T-shifting and Laplace transform of periodic functions. Then we will discuss the most important topic, that is convolution. integral equations, and then after we will discuss about the differentiation and integration of transforms, ordinary differential equations with variable coefficient. It means in last point we will apply the Laplace transform techniques to find a solution of the ordinary differential equations. So this is the content of the unit number second. In unit number third, we will discuss the Fourier integrals. In that, we will discuss the Fourier cosine integrals and Fourier sine integrals. Fourth unit is first order ODE. ODE stands for ordinary differential equations. Again I am repeating, ODE stands for ordinary differential equations. So in this unit we will discuss the various techniques to find a solution of the ordinary differential equations. In that, we will discuss the exact differential equations, linear and Bernoulli equations, equations not of first degree, equations solvable for p, equations solvable for y, equations solvable for x, and then lastly we will discuss the Clairaut's type. So this is the fourth unit. Now, in fifth unit, we will discuss the higher order ODE, stands for higher order ordinary differential equation. Unit number 4 deals with the first order. Unit number 5 deals with the higher order ordinary differential equations. So in this unit we will discuss both linear, non-linear as well as homogeneous and non-homogeneous linear ordinary differential equations of higher orders. So in this unit we will discuss about the homogeneous linear ordinary differential equation of higher order, homogeneous linear ordinary differential with constant coefficients, Euler-Cauchy equations, existence and uniqueness of the solutions, linear dependence and independence of the solutions, Wronskian, non-homogeneous ordinary differential equations, method of undetermined coefficients, and solution by variation of parameters. So this is the fifth unit, and last unit of our of your course Mathematics 2 course is series solution of ordinary differential equations. So in this unit we will discuss the series solution of ordinary differential equations, special functions, power series method, Legendre's equations, Legendre polynomials, and Frobenius methods to find the solutions of the ordinary differential equations. And lastly, we will discuss the Bessel equations, Bessel functions of first kind and their property. So, this is about the 6 different unit of your syllabus. First unit deals with vector calculus. Second unit we will discuss the Laplace transform. In third unit Fourier integrals, and last 3 units of your syllabus completely devoted to the solution of the ordinary differential equation. Fourth unit for first order, fifth unit is for higher order, and sixth unit is for series solution of ordinary differential equations. So here we have completed our today's lecture. Thank you. Have a nice day.